that you had that you'd stole.
Hi guys, welcome to the 6th lesson of this series on the terminal. An important concept to grab about shell programming is redirection and file descriptors. In one of the previous videos, I showed you how to print the content of a file using the cat command. What this command does is read every line of the file and actually write them into a pseudo file, and then the pseudo file gets displayed on your terminal. Also, there are programs that read an input, such as a user input from your keyboard. Now, let's see how that works in practice. The first thing that I'm going to demonstrate is reading from what is called standard input. This is one of these file descriptors I told you about. The second thing I will show you is how to write to standard output. It is actually the first command we wrote in lesson 1. Remember? We did exactly this. Echo hello. When you do that, the hello word is displayed or printed on the console. And where it prints it is on the standard output. Now, if we wanted to write hello to a file without opening an editor first, we can direct the standard output to a file. Using this here, I can now have it written to some file, let's say a.txt. I will, however, need to, put something here, because otherwise it would just print hello a.txt, and what we need to write is this character, bigger than, and this actually takes the output of this program and pushes it or prints it in that file. So let's execute that command. No output. And why don't we have any output? This is because all the output has now been redirected to this file. And indeed, if I look at the content of the file using the cat command, it now contains hello. There is, another way to read what is in that file. Because here I'm just using, as before, the cat command to read that file, but the cat command is also able to read from standard input. Actually, I'm going to use the less than symbol, and this will redirect what is in this file to this command. And this just so happens to do exactly the same for the cat command. And now you can see that hello gets printed again on your terminal. If you didn't understand what just happened, let's look at another example. For that purpose, I wrote a small program that simulates buying a bus ticket from your terminal. So it is going to ask where you want to go and then issue you a ticket for that destination. Let's try that. Buy bus ticket is the name of my shell script. Alright, it's now asking for destination. Let's say Berkeley. And voila, I've just been issued a bus ticket for Berkeley. Let's say I want to read the destination from a file. How can I do that? Well, I just told you. We need to have a file containing the destination. This here is the file name that will contain the output of the echo command, which all it does is print Berkeley. And again, if I look at destination, it's going to contain Berkeley. And if I execute the buy bus ticket again, now instead of using my keyboard to put my destination, I can just use the less than symbol and the file name, And now automatically you can see that my destination is here. And I've been issued a new ticket. There is something interesting here. You can see that before, when I used my keyboard, what I wrote was printed on a terminal, and now that I used a redirection from a file, well, it didn't get printed. How stupid is it to write a file to read it right afterward though? There is actually a way to avoid that, and this happens to be by connecting the standard output from the echo command to the standard input from the buy bus ticket command. In order to do that, we will use the pipe symbol, this one. So instead of having this and then this, I'm gonna combine them. So the first thing, of course, is that you have to have your destination output it to the standard output file descriptor, and then you want it to serve as standard input to the buy bus ticket command. So what will happen is that my text will flow from the echo command to the buy bus ticket command. And now you can see that I didn't have to write a file and read from it, and the buy bus ticket command just read it from the standard input. So far we have seen two file descriptors, which are standard output and standard input. There is actually a third file descriptor, and this is standard error. So if a command produces an error, usually it will be using not the standard output, but another output which is the standard error. So it just so happens that the shell script I wrote is able to produce such an output. So if I were to use a destination that is not supported, I don't know, let's say I want to go to maybe London. Well, it tells me, oh, I'm not able to sell a ticket to London, sorry. And you cannot actually see it on your terminal, but this was printed on the standard error, whereas this thing here was printed on standard output. But you can filter the standard output and the standard error. How we will do that is using a redirection. So you actually already know a way to do that. You could simply redirect the output of the command to a file. And when you do that, it's only going to redirect standard output. So again, now let's say this file should be empty, because I'm gonna produce an error, so there won't be any good output to standard output. And now you have a first problem. And the first problem is I cannot print what I wanted before, which is destination, because this is going to go to standard output. So let's just suppose there was this destination prompt, and I'm going to write something that does not exist, blah blah blah. All right, and here you have the error. And now if I look into this file, you can see it's not empty because there was this thing that I didn't think about, but you can see that this output here that I told you was going to be printed in standard error. As I said, when you use that symbol, you are going to redirect the standard output to this file. But this here is a shortcut for this. What does the 1 mean? The number 1 means standard output, and the number 2 means standard error. So when I do that, I'm going to redirect standard output to this file. And actually, it's not gonna be empty. Let's just say it's this file. Now I'm gonna say blah blah again, and you can see the error here. And if I look at the content of this file, it does contain the prompt that I had before, which is exactly the same, as you can see, as if I didn't use the number 1 here. It's very easy to get the standard error instead of the standard output in my file. I just replaced the number 1 with number 2. Now you can see that destination was printed here and it wasn't printed here because destination is being outputted to standard output, not to standard error. But if I now enter a wrong destination, the error is not shown anymore because it was printed to standard error. And now my file should contain the errors, which it does. Now one thing that will often happen is that you want both standard output and standard error to get printed to a file. And one way to do that is to use the ampersand symbol. So now if I do, let's say, and now I'm also gonna use standard input, and let's say Dublin, then nothing gets printed because standard output goes through that file and standard error also goes through that file. And if I look at the file, I should have both the prompt and the error, and indeed I do. Note that in some cases, maybe you don't want to see the errors. And so if I execute this, which here you can see the error, I can actually redirect the standard error to somewhere that I will not look. So you can either, again, use this file, or there is a file actually on your system which is like garbage, a place you can put anything, and that's not going to take any space. This file is /dev/nil, and everybody can write to that file. And now, this way, I did not print the errors. Or I can also have it like this, and this way I don't have the standard output. You see here, as I said, the standard output goes to the standard input. But what if you wanted to use the standard error and, use it as standard input? Well, for that, you would need to redirect the standard error to the standard output. And one way to do that is by using this very weird syntax. I couldn't just write 2 bigger than 1 because that would be the same as this, for instance. And the space here actually doesn't matter. I could have written the T at this position. But I don't want to write to a file named 1. I want to write to the file descriptor 1, which is a standard output. So this is why I have to use the ampersand. But now, if I read this with the cat command, you can see that both got printed or read from the cat command. But if I only had this, for some reason, that line here appeared before the other one. Here, the standard output goes to the cat command, which gets executed last, and the standard error is not used by any command as standard input, so the terminal is gonna print it. First it executes that command, and that command prints stuff, which is here this error, and afterwards it's gonna use the standard output from that command with that command that is executed last, and that command is gonna read that standard output and print it here. One last thing, you might not always want to erase your file. You might just want to append to it. So you can have several commands, and each command is going to write something at the end of the file. And the way to do that is use two bigger than symbols. So if you have, let's say, A that I write to this file, and then B, well, as you saw before, this file is only going to contain B. If you want to contain both, you have to write A. That's okay, it will replace the whole content of the file with A. But when I do B, I want to append to it like this. And now I have both. Voila, I hope you liked this video. If you have any question, just write a comment and I'll do my best to answer it.
It was the thing that you had that you'd stolen.